Okay. Alright, so today we have the task of clearing out a lot of probably no fix dead tickets. So when a device first gets here, it goes through kind of a triage process. It gets triaged, and within the same day usually I look at the device. If it's something that is most likely fixable, it gets fixed and sent out within 3 days of it arriving. However, when something ends up being a rabbit hole, it gets put in another queue and gets looked at between repairs. And today we have a collection of those rabbit hole-like boards that we need to take a look at. Some may be fixable, some may not be fixable, some may be dead CPUs, some may be NANDs, some may have some weird fault somewhere. We don't know. We have to get into it. So let's just get going here. And the first one on our list is going to be an A2251 that the customer said was never liquid damaged, and they lied. And it does not turn on, and it has corrosion by... It had corrosion by Ocarina. Ocarina had minor findings on... It was just not really consistent with anything much. It was just slight corrosion. There was no solder ball damage or anything. Let's go down here. Let me find my ticket here. 6029. Okay. Alright, let's go. So here's our board. It's an A2251. Not A2259. A2251 2020 Intel MacBook Air. Intel MacBook Pro. With no power after liquid damage. Inspection revealed corrosion around the left side CD3217s and corrosion around Ocarina, other non-specific, really minor areas of corrosion. So let's jump right into this and let's go. So let's go into our microscope. Get our microscope light on. I'm going to get my chat over here so I can see what I'm doing. Paul Daniels is here. Barry's here. I mean, not Paul Daniels, Peter. Australians always get mixed up. How did I get Peter mixed up with Paul Daniels? I feel bad now. Alright. So let's just look. We have some corrosion near the PP bus MOSFET. That's our backlight MOSFET corrosion. Other areas just really don't care about any of this stuff. Let's see what our symptoms are. CPU MOSFET has some corrosion. PMIC area is clean. The main area I'm concerned about is this guy right here, Ocarina. Now, Ocarina is the PMIC for the SSD, and whenever this gets corroded, this has the potential to kill the SSD. So the first thing I'm going to do, and I believe we did do just a little flux on here. Little flux and heat, which can resolve some issues occasionally. And let's see. So the first thing I like to do is I like to check resistance to ground on these rails, because oftentimes when the SSD is dead, these will be very low. So let's go ahead and check resistance to ground. And we have 232 ohms, 230 ohms, and 32 kilo ohms. That's up there. Ah, this may actually not be dead. The 2V5 has millions of ohms. This fares very well for an okay NAND. Anyway, let's go ahead and get Ocarina replaced, because Ocarina, when it fails, can cause issues like this. So let's first, before I start replacing stuff, let's go ahead and first off, when this board first presented, we did localized reflow of the Ocarina PM IC, and that did not solve the issue. Now there was no signs of solder ball damage under here, but oftentimes a localized reflow with a little bit of flux and heat, followed by ultrasonic cleaning, will resolve the issue. It did not in this case. However, one thing that did throw me off is I measured resistance, and on the 2V5 circuit, and it was low. It was really low, and that's not a good thing. However, the NANDs, as temperature increases, the resistance will decrease. So if the NAND was still like maybe around 120 degrees, resistance can be low. But anyway, let me go ahead and plug this in, and I need my USB port here, and these things always like to run away. I just got a new one over here, and it ran away. So I gotta find that. It either ran away or is attached to a board. So let me find my USB port before we get started. Christian's here, computer booster's here, computer booter is here, I should say. Richard is here. Alright, let's grab USB-C port. Here we are. This one's corroded. Any others? Any others? Nope. Alright, this one will do just fine. Okay. So, we have nothing. Or do we? 20 volts and 0.04, 0.016, 0.12. What this tells me... Oh, now we're booting. Okay, so that is booting current. And I feel my CPU getting warm too. That's abnormal how this is acting. So intermittent issues are often caused by corrosion like that. I don't like how this amp draw is at all. But this is a 10th generation Intel CPU, so this is, I believe, Cannon Lake 0.6. No, this seems to be booting, since I still have VCORE. Yeah, this seems alright. Let me go ahead and I'm going to replace Ocarina, because Ocarina can cause issues, weird intermittent issues, and given the history of liquid right here, that can definitely do it, as well as touch up the resistors around here. I'm going to take a look at any imaging we may have on this board here, so just give me a second. I'm going to review some images, and we're going to see if we have any findings that are consistent with anything wrong around Ocarina. Let's see here. Open up Parsec on a different computer, I should say. Get this switched over. Okay, 6029. What do I have on 6029? Yep, do have some. Let's have a look. This is what I care about, and this is what I care about. And Ocarina may actually be good, but I don't trust it, and there's one resistor here that has some slight corrosion. Okay. Continuing on. There's, yeah, right here. Okay, so let's get our iron on. Yeah, the new boards can troll you on current draw. Also, this thing here, take this off whenever you're working on 2251, because you'll see stuff will hide under here. Alright. Yeah, see that? I've got to take that off. Got to look. Alright, that's no good. Let's see what this is. If this is a resistor, I've got to see exactly what this does. Yeah, that's a capacitor. Those don't look too good either. If they're on PP bus, alright, so that capacitor just flung right off. And yeah, we'll see what these do and see if they're important. And that looks important right there. To see if that's actually a via or just a probe point. That got hot right there. You could see right there, that really, really got hot. Anytime you see rainbow like that, it's either corrosion or it got hot. And one thing to tell, you could just clean it up, and if it doesn't go away, that area got hot. For sure. This is fine. Little flux on that. That's just good as new. But yeah, that got hot right there. What's on the other side of this? Yeah, it's just what happened was, you see right here, there's ground. Somehow, I don't say again, I don't know if this is a reaction with the material or if it got hot, but that looks like there was some heat there. Alright, so let's get started. Ocarina, let's get Ocarina replaced. I have connectors and NAND here, so I'm going to use low heat, and I'm going to switch my nozzle as well. So let's get a little bit of flux. NC560 NC559 for ease of cleaning in the ultrasonic. I'm going to select my 6mm bent tip nozzle for this. The scroll lock is what? Alright. I'm going to do 395 and 430, 120 actually, because my nozzle is. Take note of our orientation. Always, always, always. The dot is in the bottom right corner. And I haven't really eaten today, so I'm a little bit shaky, but we'll make this work. Most likely this chip was fine, but I don't trust it. Luke says he is testing out a laptop with this stream. There's that. Let's clean this up. And have a look. That looks good. I'm not going to wick this. I always say I'm not going to wick it. It always ends up going wrong, but I'm not going to wick this today. Do I have any pre-balled ocarinas? And let's get the ultrasonic on while I'm thinking of it. That was a static shock I just got in my ultrasonic cleaner. Let's see, Ocarina. Where's Ocarina? Here we go. Are these Ocarina? That's ISL 9240s. These do not look like Ocarina. These also do not look like Ocarina. This is what I need right here, and of course the reel is empty. So that means I'm gonna have to pull one. What are these here? That's an empty reel. Wait a second. Aha, I might have one. Let's see, is there a stray Ocarina in here? Ocarina is the code name for this PMIC, if anyone's wondering. I'm gonna grab something to drink real quick. I will be right back. Do we have a stray Ocarina in here? Ah, that is a stray Ocarina I see in this reel. This clearly very new reel with dust inside of it from China. You gotta know, when China says new, it's 100% new every single time. Yeah, this is a new chip. Look at that. Look at that beautiful new chip that just ran away. No, this is a reball, but it looks good enough. Yeah, you could tell that's a reball. You could tell the flux residue, but I don't care. As long as it works. As long as it works, we're fine. Okay. We're going to get this guy aligned. There we go. 430/60 now to put it on. We're going to keep, and you can see no, get back here, little chip. I know I wouldn't want to be on this board either. This is why I recommend wicking, because it's so much easier to put the chip on, but that looks good. There we go. Come on, go into place. Go into place. You could do it, little chip, little Ocarina. You could do it. I believe in you. The solder color is fine. Solder does that. Solder's an alloy, so yeah, that's totally normal. Alright. Just want to see, because I did nudge it a little bit funny. All looks good. Okay, so that's taken care of. Now this right here. Is this capacitor important, or can I just forget about it and not bother with it? So I used to be very picky on what I would put every capacitor back on, and the fact of the matter is, it's near the CPU. If I don't have to unnecessarily heat in that area, I'm not going to unnecessarily heat in that area. So let's see what this does exactly. This probably is important. 37703. Critical. Alright, so this is something that I need to put back on. This is going directly from... This is right on the output of a chip, and this is something I would consider very important. Okay? Not that one, this one. Alright. I'm not leaving that off. Now... This other guy here that has a ripped pad, C7701, you're just a little desense capacitor. I don't care about you. I'm not going to bother putting that back on. So, let's get the heatsink off. And let's take care of that 2.2 microfarad. This is an A2251 MacBook Pro that does not work, or did not work. It's going to work now. Okay, let's get the heatsink off. How is the stream quality for everyone in chat? We're streaming at 4K. Are we streaming at 4K? Or are we streaming at 1080p? Are we streaming at 4K or 1080p? Holy crap, we are streaming at 4K. This laptop is streaming at 4K. This thing, okay, so I've I used to have a work computer. My work computer was an M1 Mac Mini, which is now sitting here. My home computer was a Ryzen desktop. And then I bought this ThinkPad T15G, and it has a Core i9. And let me tell you something. So the Ryzen 5 5600X or something, I don't know what it had, that I was using to record, could not. I recorded in 4K in it, and it just it had like the frame rate was low. It couldn't maintain 60 FPS on recording in 4K. It just overall wasn't. It just didn't. It didn't do well. The M1 did not do well recording in 4K with multiple video sources. That's the thing, multiple video sources. This ThinkPad does just fine. And if I look at my CPU usage, if I look at my CPU usage here, look at this. Why is the fuse on the 2012 A1278 smaller than the 2010 smaller than the 2012? That's a question for an Apple engineer, but replace it. You can replace that with the bigger one. Just, you know, kind of finagle it in there. Well, that's fine. So yeah, look at this. (21%) 4.7 gigahertz, 27% memory, and 71%. And notice that our GPU is not burning. I mean, our GPU is not burning. It's not bad. Okay, back to work. Off topic. And it's also, I should say this, while it is streaming in 4K, it is driving the my 4K 32-inch and my 4K laptop display. That's not bad. 8K of display while streaming 4K, that's not bad. All right, enough. I talked too much about that. I tried an M1 Pro, and same thing. It, like in OBS, having multiple video sources really slowed down. Look at this. When I look at the Apple original paste, look at the pump out effect on this. So this, most likely the paste started here and it just migrated outward on that. And you can see there isn't that much thermal paste left on the die, and this is only a 2020. So that's not very good. Anyway, continuing. This guy right here, you gotta go. Now, the thing is, this capacitor is most likely reading just fine. The problem is, it's a liability leaving something like this on the board. Let's get this guy out of here. Yeah, that's a liability, leaving something like this here. So we're going to take this off, and I'm going to position my board like this, so I'm positioning heat away from the CPU. And I want to limit as much heat as I can from here, so I'm actually going to try and just knock it off, just like that. And that means we don't have to use unnecessary heat. I could use a lower temperature to put this on, and we're good. So let's go ahead and clean this up. Just like that. And let's go ahead and find a similar capacitor. And this is, what was our voltage? 2.2 is 1V8, 2.2 and 25 volt rating. All right. Let's go find a similar cap. Let's open a 01598 because that's easy. And 1V8. Prim PCH. And 4.7. I need a 2.2. A 4.7 isn't going to work. But this guy, 0.1, that's not going to work. I'm hunting for a capacitor on a donor board, if someone's wondering what I'm doing. 20. If it's just a simple decoupling, I can use just anything, but on outputs of chips like that, I like to do one that's at least close. 20, these are all 20, 1, 1, 1. 2, I need a 2.2. '20s, all 20s. Alright, whatever. We're gonna open schematic in Adobe and just search 2.2 because this isn't the power sequence, not what I want. Schematic diagram, open 2.2 UF. That's a little bit too small. That's a 201. I need a 402. Here we go. 402 X6S 25 volt critical, and it's a no stuff. Lovely. No stuff. $201. $201, $201, $201, $201, $201. $201, $201. Let's try a 2141 board. One thing I could do too is just stack 1 microfarad. That would be fine too, but I don't really want to do that. That's something you see in a lot of medical equipment. Like a lot of medical equipment has stacked capacitors like that. There's nothing necessarily wrong with that practice, but I prefer not to do it because it's ugly. Two oh ones, 201, 201, 201, 201. Mm. 2402. Let me check chat real quick. Have you ever worked on the new A2442? Yes, I have. I actually bought one to measure stuff on it, and it was a pain to take the board out. All this for a capacitor that's probably doesn't even need to be put on there. $201, $201, $201. All right, you know what we're gonna do? We're gonna do a 4.7. Going with a higher value is not gonna hurt anything. And if I have one in 402, 10 volt. All right, so 402, 10 volts, X5R. This is, how many volts is this? It can't be more than, it was 1 V8, wasn't it? PPVIN. Oh, VIN. This is. Oh, this is just PP bus. This is just PP bus. That's why it has a 20. Okay, this is just the VIN from PP bus. Screw that. I'm not putting that back. That's not needed. Yeah, that's just the VIN from PP bus. We don't care about that. That's already regulated enough. Yeah. I don't care about a VIN from PP bus. And there is something that requires my immediate attention right now, so I'm going to take a look at this, but it should only take me a few minutes. Yeah, all that capacitor does is just smooth out the input on PP bus, and PP bus is already very well regulated, so we don't need to worry about it. Okay, 1 second. I gotta take a look at this. Okay. Did anyone else hear a cat? I hope there's not a cat in here. Alright, so let's look. Anything else that we need to do? That's fine. That'll clean up just fine in the ultrasonic. Same here. Let's give this a little flux and heat. Flux. We're good there. Let's let it cool, then we're ready to test. Just grab this enclosure here. Everything else looks good. Definitely gonna need to do a more thorough inspection on this, but it looks all right. Don't want to set that down in flux, which I already did. Let's clean that. Okay, let's do this. Please work. I better test the Mac before I put it back in the enclosure. I can't tell you how many times I've done that. I've thought something works, and I even don't even test it. I just put it in the ultrasonic queue, and then Caleb reassembles it, and then comes back and says, "Hey, it doesn't work." And yeah, because I replaced something funny. Something happened. Alright. USB-C port. Better put the heatsink on. I don't want it to thermal trip and then get trolled because it didn't. $20 volts, 0.05, 0.06. Come on, give me more. 16, good, good, good. 21, 26. Caleb, did you just remote into that frickin' iMac? Screw you. What the hell? That's not good. Do you have remote software on that iMac? Wait, that's your iMac. I don't care. Alright, do we have VCORE? No VCORE. Why don't we have VCORE? Uh-oh. What happened? Something happened. We don't have VCORE. I gotta shut that iMac off. I don't want, untrustworthy employee playing anything on there that shouldn't be played at work. Do we have VCORE? Come on, give me VCORE. Give me VCORE. I'm gonna unplug that damn thing. Why don't we have VCORE? Or I think we might just be getting trolled. Actively trolled. Alright, I have, so I don't, the power sequences and all these new CPUs are really weird. And sometimes what you can get is it'll boot on VCORE, then it switches to like an auxiliary PCH line because it's running on its low power section of the chip. So I've seen that before where it's like, okay, we don't have VCORE, but why is it booting? Well, it's switching to an auxiliary power source because it's either throttled severely. And another thing is I had the heatsink wasn't mounted. And the newer Intel stuff is like really, really good at maintaining its thermals in spec. So it will cut voltage relatively quickly, and I don't know exactly how it does that. It may resort to running off of a PCH line. I don't know. But the new Intel chips are very, very smart as far as controlling their thermals, and they really can get, you can really get a lot of performance out of them while still maintaining, okay thermals. And a lot of people see that and they're like, oh, my CPU is running at 100 Celsius, it's going to die. Well, no, it's really not. That's normal. Because they're pretty good at boosting their clock speeds and maintaining a thermal envelope. Like, for example, look at my laptop here. This is a laptop. Again, I shouldn't talk about this, but if I were to check my CPU, it's going to be at 100 Celsius right now. Okay. Core temperature, 92 Celsius, 99 Celsius at 40 watts. And that's normal for these. They're going to boost their clock up until they hit their thermal limit for performance. You give them a better cooling solution, guess what? They're going to up their clock. And their TDP. I really don't need, something feels like it. There we go. Okay, so I really don't need everything plugged into this. I want trackpad plugged in, and I want screen plugged in, and a USB-C port. And we're going to see if this gives me an Apple logo, it sees the SSD and all that good stuff. And hopefully it does. Oh, heatsink, heatsink, heatsink. No, I don't want you to thermal throttle. You know what, let's give this a little fresh paste. I'm just going to use, let's see, the closest tube of whatever kind of thermal compound is in reach is what's going to get used. Anything to transfer heat to the die. I'm going to use carbon black because we're not clamping down the heatsink. And it is good for loose clearances like that, so I'll just put a little bit on there. And put the heatsink on. There. Come on, little MacBook. Please, 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 please give me VCORE. Something. anything. So I had VCORE. Now I don't. I don't have an Apple logo. Alright, I have all the power rails I need, but no VCORE. It's like it's trying to. Or do we have some... I love the operating tray. Yeah, they are. I'm using thermal pad on my MacBook Air heatsink. Well, thermal pad is definitely better than thermal paste on the MacBooks that use that black thermal paste. Than using regular thermal paste, I should say. Alright, does this... I wouldn't think this needs a battery or anything. But it is concerning for a dead CPU, given the fact that we had corrosion on our MOSFET. Hopefully it's not a dead CPU. I don't want to have to tell another person that MacBook is dead today. $22, $25, $17, $14. Nothing. I have trackpad click, I have some PCH power, but no VCORE. That is interesting. Alright, so we had VCORE. Let's pull this out. We gotta test some stuff. Does this need a battery? Does the 2250... Let's find out. Do I have a battery screw right here? Please have a battery screw. Because some of them are weird and they need the battery. If MacBook did, you pass away, said Caleb. I had i9 2.9 in MacBook P that would shut off quickly without heatsink on. CPU would ramp. Well, yeah, if you have no heatsink on it, then it's going to shut off quickly. The only ones that could run without a heatsink are like the low voltage chips. Like the Intel Y series. I wonder, you know what? I've seen this before on like the 2141s if the heatsink isn't actually mounted. So I'm going to pull this off. I'm going to apply some regular thermal paste. Because remember, carbon black isn't really intended to be used like this. And I'm going to mount the heatsink down because it was working before. And then once we took the heatsink off, it stopped working. So this isn't, like I said, this paste really isn't made for this. So let's go ahead and clean this up. Let's actually mount the heatsink down with pressure. And go from there. That's clean. That's clean. Let's get our choice thermal paste that I got thermal paste all over my hand. The current thermal paste we like most for this application is HY880. I didn't have paste on the eDRAM die, so that might have something to do with it. I've seen this before. I've seen boards not turn on because the heatsink mounting pressure is off. It's not the fact that it can't electrically, it's more the CPU saying, hey, something's wrong here, my temperature's rising too fast, shut down. And it asserts the processor hot signal to the ISL chip that controls power to the MOSFETs, and it shuts it down. Shuts down voltage regulation to it. And that's not something you really want. Because if it's telling it to shut down, then, you know. It was on bench with nothing else attached. Yeah, that's one thing. But also we tested on the bench and it wasn't giving us VCORE either. But the only difference is our heatsink wasn't mounted. And that's a big difference, so. Okay, our heatsink is mounted now. There's pressure on it. Let's go ahead and check and see if we get the same amp draw. And that is definitely something I need to note in Repair Wiki, that these do need a heatsink, if that's true. 20 volts, 0.03, 0.04, 0.13, 0.15, 0.16, 0.13, 0.12, 0.11. Alright, no changes there. Try VCORE again. No VCORE. Do I get a pulse? Anything? Let's unplug this. No pulse. So, one second, let me reply to a message. Okay, let's look. So we clean this up. It's honestly really unlikely to do anything. Aha! You! What are you? I remember this. We clean this area. Is this important? Is there a via here, or is this just a standard probe point? This looks like just a standard probe point. But another thing is right here. Was a via connecting this maybe? Don't think so, but I'll check. No 4K capture card here. I'm using a cheap, the microscope is 1080p. 4K microscope doesn't really make sense, so the microscope's running off of a 4K, I mean a 1080p capture card type thing. Alright, this is just a probe point. That's nothing. This right here might very well be, this other one, a via that's important. Let's see. Where's my inductor here? Yeah, 1v8 prim might cause an issue. Okay. 12 volts. My amp jar went back up for a second there. Interesting. Very, very interesting. Ah, what's this? Okay. I did not notice this. I did not notice this at all. Alright, so we had liquid on this side. Do we have any around here? No. Yeah, this looks like it was, let's see. It looks good. This was a capacitor here. Nothing around the chip, but is this an important capacitor by chance? No, it is not. So I don't care. I didn't notice that because it was under that shield type thing, and it must have been ripped off when I pulled that off, because that's what happens. Alright, so I want to check prim voltage now. See if anything's wrong there. But this intermittent thing, this is kind of more of like an ultrasonic cut type thing. But it's just weird. It could be one little thing that we're missing. I really wouldn't think it would be a bad Ocarina, but you never know. Alright, here's the prim regulator. Just check this voltage here. That inductor is not cracked, I don't believe. It looks like it is, but it's not. Something on top of it. I have 1.8 volts here. .8 volts. Okay, so it's not that. .8, 1.8. Okay. Do I have my enables for CPU VR reg? Let's see here. CPU VR EN right here, end resistor. CPU VR EN. I'm gonna guess no. Which means our CPU might not have serial communication there, which might mean it's dead, and that's sad if it is dead. I have some voltage there, it's really low. If it has low voltage there, that makes me think it's kind of being enabled, that maybe the chip is bad. So what I'm going to do, how do I rule out this chip? I'm going to take this resistor, I'm going to disconnect this resistor from the chip, and if it goes up, that tells me this chip is pulling that down internally. I have a little flux, as usual. Gonna move it to the side. We're gonna check voltage again, and that'll tell us what's going on. This is not a 2020 board, Peter. This is an A2251 820001949. Okay. It's cool enough to try again. Amp draw is higher. And around the same voltage. That could mean that the P stage isn't enabling it fully, or something else going on, or there's an issue with our CPU. I don't suspect the chip is bad though. We're gonna put this back on. Trying to think what the method might be for this happening, because it always happens in some way. So there's no chance of that being it, that little capacitor. But you know what? I'm going to replace it. I got to find a 2.2 microfarad just because it's a change, and I want to rule out a change. We have a change here. We changed something on the board, and now it's not working compared to where it was. It wasn't working to begin with, but... Okay. Let's go to the donor board store. There we go. Come on. Come off. There, finally. This other resistor here. This one. Yeah, I can't see that causing an issue. Just this presentation is just really, really weird, and it makes me think there's corrosion under something, or the CPU got its voltage spike from that MOSFET. Let's just do some flux and heat on this. Actually, before I do that, what's resistance to ground on the CPU VCORE rails? Okay, that ain't right. Kiloohms? That's not right at all. Is something, are we being trolled? We should not have kiloohms on CPU. That is a big, big problem. That's like dead CPU type stuff, like blown out inside CPU type stuff. Just think we're getting trolled though. There. There we go, 70 ohms. That's good. 70 ohms. Okay, better. Okay, we're gonna let it cool. And while it's cooling, I just want to think, what else could do this? So what we know, this happened after liquid damage. When it came in, it had no power. It was getting stuck fairly high on the power sequence from Ocarina not working. Ocarina started working, the board turned on. We replaced Ocarina, then nothing. Could it be a bad Ocarina? Very, 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 very unlikely. It's worth a shot on another one, but it just doesn't seem plausible. But let's see. Right now, the most likely diagnosis is either corrosion under the CPU or the CPU has died in some way from voltage spike. 20 volts, 0.04, 0.05, 0.012, 0.010, 0.24, 0.12. Just wait for it, 0.13, 0.14, 0.12. You know what? I want to connect the battery. This just isn't adding up. It's like, all right, now our CPU is warm, but what is VCORE? It's acting like an A1990X when the battery's disconnected. Have aux voltage. It's almost like I do get a pulse. Yeah, let's connect the battery. This is, yeah, we need to rule that out. Okay. I need to order food. I'm getting hungry. Soon. Corbin is here. Hello, Corbin. Email? Not a good email. I don't like not good emails. This isn't NAND. NAND wouldn't do this because the fact that it's getting that far down the line, it's telling me Bridge OS has already been loaded. So it's not the NAND. So we can cross out the NAND. Where's this cable? Come back here, little cable. Here we go. Come back. There you are. Remember I had a board doing something similar? And I was putting it in the enclosure and it wasn't sitting right. And there ended up being a magnet stuck under it. But that's not the case. There's no magnet stuck under here. This MacBook is having an identity crisis, Kopaz. Wait. VCCIO. Does this have VCCIO voltage? I've seen, let's see. VCC. No. Okay. Come on, connect. Connect little port. There we go. Okay. Just gonna try. We don't need speakers. Actually, speakers would be helpful because for all we know, this is. Yeah. I'm gonna connect a speaker. It's getting stuck at the very last stage of the power sequence, and that's the problem. Is it's very. That stage of the power sequence is the worst stage to get stuck at, unfortunately. Okay, this is almost done. Do I have a spare battery screw here? Nope. Alright. I grab his original. And the screws are missing from his original. Lovely. Battery screw, battery screw, battery screw. battery screw. Alright, so it's just the sequencing with T2s is just weird, and you can have issues like this. So there's a signal called PM bat low L, and if for whatever reason, okay, there was corrosion around our CD3217s, maybe there's some weird communication going on and it's not identifying the charger properly. I don't know, and that's my phone. So I'm gonna be right back. A clue, we have our battery connected, and our battery board is, let's see, or do we not have our battery connected? It's not it wasn't charging, and I just touched the cable and it fell out. So let's go ahead and make sure our battery cable is properly connected. Come on. If it's not charging, that tells me something else is at play here. Alright, so if it doesn't charge, so charging, so if for whatever reason the board, we're getting to high up in the power sequence, but it's not charging, that makes me think something low level is going on. Meaning something like T2 firmware, maybe CD3217 messing with firmware. Yeah, it's not charged. Okay, 0.28, spiked up, 0.12. I get trackpad click, so the T2 is somewhat present. This is acting almost like it's in recovery mode, kind of. Which I've seen after Ocarina. Alright. So the best thing I'm going to do right now is we're going to force this into DFU, and we're going to do a DFU restore. That rules out any firmware incompatibilities with Ocarina. I've seen it a couple times. It's not common, but it seems most plausible at this time. Because my power draw should have went up. Like, there's no question about that. Let's just see if it's in recovery just for the heck of it. Try a different port. But it's acting very much like something like that going on. So I'm going to plug it into this machine right here. For all I know, my battery's totally dead too. So let's see. Check chat real quick. Galvani is here. And another spammer is here as well. Okay. Let's close this out. And configurator 2. No, nothing. Alright, so let's try and force this into DFU. Sometimes you could do it via the just by putting our tweezers across it. Otherwise, we run a wire. Let's see, SOC force DFU. Where's SOC force DFU? Right here. Okay, so I'm just gonna get my tweezers across this big switch right here. Wait a second here. Before I do it, got it. Okay, and if I don't want to touch this to ground or anything. Alright, so as soon as I unplug anything, the power just shuts right off, which is a bit odd. Alright, try and reseat this again. Alright, 0.33, 0.49, 61, 42, 43. Now it's acting like VCORE is present. Now this is acting more like VCORE is present. I have high amperage, and that's what I like to see. No VCORE. Aha, okay, my VCC supply is unstable. That's why. That makes sense. What's PP bus? Alright, PP bus is 9 voltage charging the battery. So I just probed around and I wanted to see my VCC voltage. And before I just kind of held it there, I just kind of, it just died. That's not good. Anyway, so before I just kind of checked voltage. Oh, it's there, and I moved on. But if I hold my meter here on our VCC voltage, let's see, where is it? No, this side. Now it's totally missing. There we go. Now it's stable. Interesting. It was not stable a minute ago. Let's power cycle it again. No, look at that behavior. It just did it. Alright, now we're pulling over an amp. So that's getting there. Why are we pulling over an amp is the question. When it's not turning on, do we have a short? And furthermore, we don't have... It's charging the battery now. That's a good sign. Just see something. Trackpad click, no caps lock. Did that fan just spin, or is my eyes playing tricks on me? I could have sworn alright, now we're pulling over 2 amps. That's really weird to be that high unless it's just actively charging the battery. Alright, it just pulsed to 7. I have a feeling I'm getting... Wait a second. Oh, what a troll. What a frickin' troll. I can't wait to show you guys this. I literally can't wait to show you guys this. This is amazing. This is amazing. Oh, this is exciting. This is really, really exciting. You guys aren't gonna this, and I see it now, and I've had this before. It is the biggest troll ever, and it correlates with what we did. This is good. This is golden. This is golden, and I could see it from here, and it's something that could be confused so often for a normal finding. This is just golden. And I always tell people this, whenever you have a voltage that is, so there's a difference between cycling and just behaving funny, okay? So what do we connect it to? Typically cycling voltages go down to 0, okay? 1.8, 0, 1.8, 0. Not 1.8, 1.7, 1.6, 0.6, 1.8, whatever. They're usually, they're very stable, 1.8 and... let's see. This is I'm so glad I got this on video. This is gonna be this is a troll. I can't. This is something that. What are we connected to? Is there something plugged in? Oh, this. I don't want to rip this. What is this even for? Just that auxiliary cable. Okay, this is amazing. Oh, I love findings like this. Okay, let's have a look. Here's our VCC coil right here to our CPU, right? Look at this side. Look at this side. All right, see that little bit of rust right there? Let's plug this in. All right, and one thing I noticed is when probing around, zero volts, 1.8 volts, 1.8 volts. Now it's 1.8. Before it was 0. 1.8, 1.8. Went down. 0.3. If I just disturb this ever so slightly, it behaves funny. Okay? I'm fairly certain this is disconnected internally. See, now it's behaving fine. But before, it wasn't. Or I just got trolled again. Let's see. So, I've seen this before several times. Let's just get this off and replace it. It's just that weird voltage irregularity threw me off. It's just still hot. No. Because I noticed as soon as I touched that, it was fine. And if that rail doesn't sequence the right time, it's going to throw things off. So, flux. Turn this. See that? That is not a normal thing to see on the coil. And if it looks that bad, who knows how it looks on the inside. Let's pull one off a donor real fast. That is a troll. That is corrosion, Copaz. Alright, just to compare, this is what a new coil looks like. Alright, see that? It looks clean, it looks good. It doesn't look like the other one did. There's not enough solder on this. I don't know if this was the issue though, but that voltage was not stable. And that's not a good thing that it wasn't stable, obviously. And it does correlate with us taking off this thing and that little shield thing. Let's let it cool and let's test and see if this was our problem. I think you turn it upside down. It's a coil. The orientation of a coil does not matter. It is a wire around an inductor. I mean, a wire around a ferrite core. Okay, maybe it's cool now. Cool enough. And what do we get? What do we get? Do we get the same amp drop? Please no. Please tell me this is going to boot normally. If it goes high, 10. Come on, go higher. Come on, do it again. No. Okay. Still no VCORE. I have stable voltage now. But still no VCORE. Alright, well, that was one potential issue. But still no VCORE. Let's do a DFU restore real quick. I just want to see if that's going to solve it. Because you can have issues like that after an Ocarina replacement, so we're just going to bridge these two pads here. And we're going to boot this into DFU. My hands have flux all over them. I hate getting flux on my hands. It sucks. Travis is here. Those two pads are the forced DFU pads. And I find it to be more reliable on the 2020 machines to force it into DFU and leave it in DFU than let it go in and out as it pleases. This flex cable is being weird. Come on. Yep, those pads are just to boot DFU, nothing else. This is one of those boards that I just feel so close to solving it. Fan under the board. Of course, there's always going to be a cable that we leave under the board. Do you have an M1, Caleb? This isn't an M1 board. This is an Intel board. Warren is here. Hello, Warren. I don't find these rabbit hole jobs very satisfying. I find they bring sadness and disappointment and frustration. The regular M1, the 13-inch Air and Pro are easy to repair. The 14 and 16-inch don't look like they're easy to repair. We don't need speakers. We do want a battery. I really want this board to work. I really, really want this board to work. And there's a potential that the power supply for the VCCIN was damaged too by that, because if it's spiking loads, that's not good for it. So I'm going to check, again, I'm going to check voltage. No, I can't. It's in DFU. All right, let's just go for a DFU restore. I can't reach. As long as I have battery, we're good. All right, we're in DFU. You know what? I want a power supply connected. Do I have a longer USB cable over here? Let me see. Small reach. I need a long charge cable. is a Thunderbolt cable. I don't need Thunderbolt for this. All right, DFU. Switch my Mac, DFU, actions, advanced, revive device. Trackpad click. If it restores successfully, I can rule out T2. And voltage is steady. No VCORE. No VCORE. No VCORE. 1.8. 1.8. Nothing. Okay. Give it time. What are those orange cabinets? It's a stand display for the front the front is when we put posters and stuff on them. If you're talking about that orange cabinet or back there is parts. Still restoring. Still restoring. At this time, I should have gotten some sign of life from it, and I haven't. But it can take some time. What about thermal? Is anything enhancing on thermal? Thermal, I should say. Oh, something ain't right with this thing. What's going on here? Tim needs a day, not only a date, a love streamed YouTube date. What? I'm not streaming anything on YouTube. Alright, I do have a MOSFET getting abnormally hot. Well, not really. It's about 120. That's passable. Do you guys like being blinded by laser? Look into the beam and go blind. I do use the SuperCam X. I'm just using this handheld because the board is in the enclosure and it's easier. But you see this keeps shutting off. It just shut off again randomly. It's still restoring. Don't want to interrupt it or anything, so we're just going to let it go. The DFU restore can take a long time sometimes. But it should have given me some sign of life by now. There's zero way this is going to work. Just if I interrupt it now, it's going to screw up the firmware big time, so I can't interrupt it. It's like doing a BIOS flash. So we don't want to interrupt it. We just want to let it run its course and go through its processes. And until it gives us a message, then we have to keep and Caleb is trolling me. Caleb had a customer that showed up at his office at 11 p.m. and was wondering why he wasn't open. And I just got an email saying, "Hi, I was outside your Palmdale office at 2 a.m. and no one was there. Why are you not open? Your listing says open 24 hours. I was there and cannot gain access to inside. I was really hoping to be helped last night. What the hell kind of service is this? Not impressed at all. I'll be leaving my thoughts on Yelp and Twitter." Okay. That's a fake message. Still nothing. The temptation to unplug it is always really high, but you don't want to do that. If it fails, that tells me I might have an issue with the NAND or the T2. If it doesn't fail, it tells me our T2 and NAND is probably okay. So it's very important that we just let it go. It's not an operating tray, it's just a regular tray. There's two. There's one there and there's one here. And I keep my flux and stuff on it. It's really helpful to have it right adjacent. Alright, so this is going to do this. We're just going to put this aside. Let's grab. This one's the most promising out of anything else in our pile today, so. Do I want to grab another one or do I just want to wait? I think I'm just going to wait. I hate waiting. This process can last between 2 and 30 minutes, sometimes longer. Gonna let it go for a couple more minutes and we're done. I wonder. Yeah, Copaz, I really wish I had a pile of Easy A1466 no backlights. I can't count the time I had an Easy A1466 no backlight. I am on the Rossman forum occasionally. What's this MOSFET do here? Yeah, that's a DCN MOSFET. Alright. Moving on. We're going to let it do its thing. We're going to clean our station up. And we're going to move on to the next rabbit hole board. Cleaner. Which ultrasonic do you recommend? It's Crest CP500 something something. I wish I had a 1466 no backlight. Almost okay, so I don't get anything easy anymore. It's all rabbit hole boards. I don't get any easy repairs anymore. They're all diagnostic mysteries. What are you? What are you? Read barcode. Read. Don't make me stand up. Fine. Okay. Still restoring on this other one. So this is an A1989 that does not turn on. That was also in our rabbit hole pile. Let's go ahead and unplug our power from this guy. He has enough battery to hopefully last through this process. And let's see what this does. 5 volts, 0.22. 20 volts, 0.04, 0.34, 0.35, 0.41, 0.48, 0.53. So this is acting like it's basically working. Or it's just charging the battery. So we gotta probably unplug the battery and see. Let's see. No VCORE. No VCCIO. Power to our SSD. Alright, so this finished restoring DFU, right, as we said that. So it finished restoring successfully with no error. That basically rules out a T2 or an AND issue. But let me just, okay, 1 second here. 0.65. This kind of acts like a DFU as well. Okay, so we're in DFU. Let's unplug this. And let's clear our bridge real quick. And let's see if there's any change in our symptoms. Okay. 20 volts, 0.5. 0.4, 0.36, 0.05, 0.04, 0.05, 0.04, 0.15, 0.43, 0.13, 0.12, 0.13, 0.12, 0.11. Sad. Very sad. Just check voltages again. It seems like it's trying to turn on. That's what I take from this, is it's trying to turn on. But it can't for some reason. That point spike to 0.43 was very good. That's like basically almost turning on. 1.8 volts here. 1.8 volts. Nothing. Nothing. Let's unplug it. I want to see what I get on this. Yeah, honestly, this is going to be an ultrasonic case. Ultrasonic might resolve this, so I'm going to take care of that in a second here. Let me look. Alright. So this guy, this one's acting like it's in recovery mode. Let's see if I'm right. No, these machines that get in recovery mode are absolute just nightmares. Usually, I should say. And when when these A1990s, pretty much any of the 2018-19 T2 machines, yeah, it's in recovery mode. Frickin' recovery mode. Recovery mode tells me that for some reason the T2 firmware got corrupted or the NAND is corrupted. And that's not a good thing. So the only thing I could really do in this case is we're just going to start a revive here. And we're going to move on to our next one. So it's in recovery, same thing, actions, advanced, revive device. And usually we know pretty quickly when they're in recovery if it's successful or not. It's installing. And I'm pretty hungry. I'm going to order some food for me. System cannot be restored in this device. Failed to handle message status, message operation failed 0x6. Yeah, that ain't good. That's very characteristic for T2 NAND issues. So this we're not going to deal with right now. This I'm going to put in the ultrasonic. And we're going to see. We're going to do one last look over before we put it in the ultrasonic. We're going to move to our next case. I don't want to eat on live stream. I have not eaten all day today, so I need to eat something. Let me order food right now. Lovely. My phone is ringing. Calling about the machine that we spent all day on stream so far. Alright. I ordered food. Who wants a stream? Who wants a live stream that consists of a lemon? Probably some people. Lemons aren't really my thing, except if you throw them at other people. It sucks. I don't know what's wrong with this board, and anytime I can't figure out what's wrong with the board, it depresses me. It's not the fact of not making money on it. Well, somewhat it's about not making money on it. The thing is when there's something that I don't know what, fine, give me a definite diagnosis, give me a dead CPU, whatever. When something isn't adding up diagnostically, it drives me nuts. I'll have not nightmares, but I'll have dreams about the issues, and yeah, it's just not healthy. So I try and solve them. I just wonder what changed. Is it an intermittent issue? Is it something we did? Is the new Ocarina bad? What, it just doesn't add up what happened. I wouldn't think Ocarina would have anything to do with this, especially if it restored DFU successfully. So let's take one more look under the scope. Let's look here. Via. But to where? There's a via there. I could see it. Where did that go to? Let's see here. I wouldn't do it unless this resistor right here. Okay. No. There's no way. There's absolutely no way. Where is that so-called current sense resistor for this, though? It's right above this cap, but it doesn't exist. Is this the right board? Yeah. Okay, I see where they... Last thing I'm going to check before it goes in the ultrasonic. Actually, there is some slight corrosion here. Did I make it under here? No. 12.63, 12.63, 12.63, everything's good. What about over here? Somehow we're still reading 12.63 right there. 6.93, 6.93. What if the via is internally damaged to PP-bus HS CPU on the other side, because it seems like this is sourced from this side of the board? What if PP-bus isn't making it to the MOSFETs? They wouldn't have any voltage to switch from, and therefore the VCORE would be missing. And that makes sense, and that correlates with this, because this looks like it drives a via which goes right under it. And we pulled this off, and it pulled the capacitor off, and maybe it was just hanging on by just a thread. Is there a via in here? I think there is a via in here. I think there is a via here. Get out of here. I don't need you. Yeah, you I don't need for sure. That would make somewhat sense if this was the case. But no, that looks intact. Yeah, that's intact for sure. But do I have PP bus over here? I'm just going to check. Because that would explain our issue if this was the case, if PP bus wasn't making it to our FETs. .63 volts. But this PP5VG3S CPU reg comes from where? That's not stable at all. Or we're just getting trolled. It's unstable, but I think my multimeter is trolling me. I think I'm really getting trolled by my multimeter. 5.135. Steady. 5.132 and steady. 5.11 volt. What? That's the board a little bit. No, that's stable. What the heck? Okay. Alright, into the ultrasonic this goes. Not gonna waste any more time messing with this. It just needs to go in the ultrasonic. Fan spin page. I want fan spin. I really want fan spin right now. Let's go. Pull the heatsink off. And as you can see, where the ultrasonic is a mess because that's an area that Caleb maintains, which is a mess. It looks like our liquid did get pretty close to our CPU, honestly. So there is a fair chance that there is liquid under. Now I want to show you guys why we use HY880 thermal paste. Now we're going to have in a few months something very compatible to this. The HY880 stuff is a lot less prone to the pump effect because of its thick viscosity. You can see how it kind of coats there. I mean, you're always going to have pump out effect. Like even after just heating it for a few minutes, you can see evidence of the pump out effect right there. But the large particles in this make it a lot less susceptible to that than other pastes. It's very close to the original stuff that Apple uses. We're going to clean this off. So when I look at this, I see that liquid was very close to our CPU, which is always of a concern. So right there, could have got under there, and right here. Not under our shield for the RAM though, which is a good thing. But buggy audio, I'll change my batteries. Can somebody else, like Caleb or Bryce, confirm that the audio is actually buggy? Because Mike is skipping. Okay. That should be better. Alright, so I'm probably gonna take a break for lunch. Let's see, where's my food at? No, we got a ways to go.